Hi everyone, welcome to Trigonometry. Today we explore lesson 8, applications of trigonometry in measurements. Number 1, applications in arc length and area. Let's take a look at a circle of radius r. We can have an angle theta right here. And this part of the circumference, we call it the arc length. S. Notice that S is a fraction of the circumference. A fraction is theta over 2 pi. Circumference 2 pi r. And therefore, the arc length is theta r. Next, well, there's an area right here. This area is called the area of a circular sector. And that is also a fraction of area. A fraction, theta over 2 pi. Area, pi r square. So A is half of theta r square. Super cool formula. Let's see how we apply them. Example 1. CDA is located at 42 degrees and CDB is located at 34 degrees. The radius of the Earth is 6,400 kilometers. Find the distance between the two CDs. Let's sketch out the Earth circle. Okay, so that's the center right here. We have a CDA at a 42 degree. So the CDA. CDB is at a 34 degree. The distance between them is the arc length D. D is the same as the arc length. And that would be theta multiplied to the radius r. Well, we know the angle theta is just the difference between the two CDs. 42 degree minus 34 degree. The radius is 6,400. So plug this in the calculator. And we have oh, you have to be careful. You will not get the answer because if you plug this directly in the calculator, it will be a number that's in degree. So what we need to do is that we need to convert it to radian. So we have 8 degrees multiplied by pi over 180 degrees. Yep, and multiply by 6400. Now everything is in radian, and ta-da! Put this in the calculator, and we have 893.6 kilometer. Very cool. Let's take a look at example 2. Find the area of the land lot. We do have this land lot because what happened is that sometimes the land is run a border with the freeway. So this is the freeway or highway. Yeah. There are two areas. Area 1, area 2. So the area is area 1 plus area 2. Area 1 is the area of a circular sector. Area 2 is the area of triangle. Area of the circular sector, half of theta or square. Area of a triangle, half of base times height. Using Pythagorean theorem, half of the angle theta is 0.3, because 60 degrees is the same as 0.3. We need the unit to be in radian. R square is from the Pythagorean theorem, 30 square plus 40 square. Now for the area of the triangle, half base is 30, height is 40. Wow. Put everything into the calculator and ta-da! 1908.9 is the answer. Unit is square meter. 2 applications in circular motion. Let's imagine we have an object rotating in a circular path. That looks like a picture. Then there are 2 speeds. The object will have a linear speed. That will always be distance travel over the time interval. Distance here is when we travel in a circular path, the distance is the arc length. And the time is t, arc length is s over t. We know s is just the angle multiplied to the radius over t. So this is the formula for linear speed. Oh, we also have the angle theta, so we can figure out the angular speed, which is the change in angle over change in time. The angle is theta, the time is t. Very cool. Similar to the previous section, make sure that the angular speed is measured in radian. Theta must be in radian. Let's take a look at some example. Example number 1. The human joint can be flexed the fastest at the wrist, which can rotate through a 90-degree angle in 0.045 seconds while holding a tennis racket. Find the angular speed of a human swinging a tennis racket. If the distance from the tip of the racket to the wrist joint is 2 feet, find the speed at the tip of the racket in miles per hour. Oh, interesting. Let's see how we do this. First is that I would suggest to sketch out a picture. So this one would be the tip of tennis racket. So down here we have a wrist joint. Right. And the distance there's 2 feet. When we do a swing, so we're gonna do a swing right here. A 90-degree angle swing. Then this would also be tip of racket. -90-degree angle. Well, from here we see that the swing is this arc length right here is S. What that tells us that we can figure out the angular speed. That would just be the angle divided by the time t. We are able to swing 90-degree angle. 90 degrees pi over 2. So pi over 2 in 0.045 seconds. And this will give us 34.9 radian per second, which is pretty fast. Yeah. Here comes a more interesting question. Now we know the distance from the tip of the racket to the wrist joint is 2 feet. What is the speed at the tip of the racket? The speed here is the linear speed. That would be distance over time. However, the distance is the arc length, S over t. We know the arc length is just the angle theta times the radius r. Pi over 2 times 2 times 0.045 seconds. And this would give us pi over 0.045 feet per second. Not sure what this number means though. It is best to convert it to mile per hour. So now we're going to do a conversion. Pi feet per 0.045 second. Well, we know 1 mile is the 5280 feet, and 1 hour is 3600 seconds. Look at the unit. The feet and the feet cancel out. The second and the second cancel out. So what we have is mile per hour. Plug this in the calculator and we have 47.59 mile per hour. Wow, pretty fast. Interesting problem. Let's take a look at another one. The tires of a bicycle having radius 13 inches are turning at a rate of 215 revolutions per minute. How fast is the bicycle traveling in mile per hour? In order to do this, we need to figure the linear speed. Linear speed is the arc length over the time t. Arc length is the angle times the radius. The angle. The angle here is say 215 revolution, meaning that the angle theta is 215. Each revolution is 2 pi. So 215 times 2 pi. To 15 times 2 pi. The radius is 13 inches. And the time it takes is 1 minute. This will give us 5590 pi inches per minute. Well, it's not a nice number, which is why we have to do the conversion. 5590 pi inches over 1 minute. Now we're gonna convert inches to mile. 1 mile is exactly 360 inches. And 1 minute is 1 hour 60 minutes. With this, then we can get rid of the inches and the minute. The answer is in mile per hour. Plug this in the calculator, 10.6 mile per hour. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel growth. I'll see you in the next video.